Hello there, my name is Fergiawan. I'm an undergraduate architecture student from Tadulako University, and in this presentation, I'm going to bring up the topic of building with climate, the art of passive design. Now, what does this topic actually mean? Building with climate here carry the meaning of concepting, designing, and even constructing a building while fully respecting the surrounding environment and also the climate. And for this topic, I present a case study of a mixed-use architectural project in Tangerang, Indonesia. It's named Kampoong Guha, designed by Real Rich Architecture Workshop. Now, why is this topic relevant and important to the ongoing development of infrastructure, not just in Indonesia but also around the world? The reason being is that as the development of infrastructure is beginning to grow more and more, people began to set aside the environmental impact caused by the construction of the building itself. And as this phenomenon continues for years and eventually decades, these practices affect the natural environment around them, which causes the average structural coverage in cities in Indonesia to change from natural structures like trees, bushes, and grass to man-made structures such as concrete, pavements, and also asphalt. Here I present some map visualization to further strengthen the relevance of this topic, especially in Palu City. The first map is a ground surface temperature map. This map shows that between 2017 and 2020, Palu experienced rising ground surface temperatures, particularly in the central area of the city, where the average surface color changes from bluish green to greenish yellow. This indicates that the surface temperature in Palu City changes about 5 degrees Celsius from around 25 degrees Celsius to 30 degrees. The next map is called NDVI, or Normalized Difference Vegetation Index map, which illustrates how dense the vegetation in some particular area is. This map particularly shows the difference of vegetation density in Palu between 2013 and 2020. Within that time frame, the vegetation here decreases rapidly from, as the color suggests, from green to yellow or from high density to almost zero. If you connect the dots here, the area where the surface temperature is increasing, the vegetation density there is decreasing, meaning that the vegetation in the area is cut down to construct the building, and also the vegetation covering the surface area is changed from trees, bushes, to hardscapes such as pavement, concrete, and the building itself. As a problem occurs, we should look for a solution. Here, as a study case, I'm taking an architecture project named Kampoong Guha. As I explained, it's designed by a rich architectural workshop. Kampoong Guha here has a meaning of cave village, which in here is manifested as a mixed-use complex that blends living, working, and also learning spaces within a dense urban neighborhood. The building is organized around a porous campus-like layout, where a series of courtyards, walkways, and terraces link together different functions such as library, architecture, studio, and co-housing. Kampoong Guha implements green architecture for its concept, which means unlike many conventional buildings that rely on mechanical cooling, Kampoong Guha here demonstrates how simulation-based design and passive strategies can shape an adaptive and low-energy architecture that is socially inclusive and environmentally respectful. Now that we know what Kampoong Guha is, let's see how it's designed to adapt to its climate. Adaptive environmental design means that the form, envelope, and landscape do most of the comfort work, so rather than depending on utilities and machines. At Kampoong Guha, airflow, paths, deep shading, and the lighting are baked into the plan and the design, so that simple maintainable surfaces are only needed to fine-tune the requirement for the comfort of its user. The result is lower energy, high comfort, and utilities that locals can build and repair easily. Here it shows the matching study, how the project grows from site to climate adaptive form. They set the footprint, carve open spaces, align the ventilation to north and south, shield the east-west side exposed to the sun, and collect water for use purposes, and finish with skylight for natural daylight and stack ventilation. After understanding how the form work with climates, now how do they design and construct Kampung Guha? So it's fairly easy to replicate with local resources and also convenient to build, maintain, and also be repaired. While applying modern materials such as steel and concrete, the architects did not forget to pay respect to the local tradition to build with material native to the environment. While implementing this concept will bring traditional architecture comes to life, it also conveniently causes the building itself to rely on local resources and craftsmanship to be built instead of importing materials and labors. Here I provide some examples on the implementation of local materials in a building, which includes bamboo on doors, gates, and also towers. Not only choosing local materials and methods to ease the process of constructing and maintaining the building, Kampong Guha also provides public spaces such as library and workshop to educate the society regarding basic knowledge and even architectural expertise. In addition to those public spaces, Kampong Guha offers tours for guests to experience the architectural masterpiece. Based on the Sun study analysis of the building in 2016, before applying green architectural concept, most of the building surface coverage are exposed to the sun for more than 5 hours a day. But in 2025, after implementing the concept, the majority of the building, the surface majority of the building, only got exposed to the sun for less than 2 hours a day. Since it is proven that the idea works at reducing the surface temperature of the building, this concept can be implemented in places with similar climates. And given that Indonesia as a country has only one climate, which is tropical climate, this means that the concept can be utilized roughly in the entirety of Indonesia. In every innovation, there will be problems and weaknesses. In this project, Really Rich Architectural Workshop found out that there are three things that will obstruct their plan on designing this building. The first one is bamboo durability. Bamboo can absorb moisture and attract fungi and insects. Hence, they use borate treatment, which is a salt that diffuses into the fibers and makes the starches of the bamboo become inedible to the insects. And then they protect it and then they protect the bamboo from rewetting or absorbing more water by not letting the bamboo to be waterlogged. Next one is wayfinding in a porous plan. A porous kampong-like layout can feel like a maze, so they add colors and texture cues, such as tinted door frames at exits and tactile pavers, so people can read the pathway at a glance and also by feeling it. Last one is landscape and water maintenance. Green vegetation and water features only work if maintained. And since the roofing of the building is designed to catch rainwater and distributes it to maintain the vegetation, the only maintenance needed on this building is to prune the leaves and water the vegetation on dry season. Now they have already proved that this concept works and also theoretically can be implemented in other areas with tropical climate. But the next question arises, why does this matter not only for one side but also for neighborhood across the whole Indonesia? The first point is that they design comfort as an integrated system, form, passive strategies, and right size services. That means lower energy, simpler maintenance, and reliability communities can actually afford, not some high tech solution that will fail without experts and specialists. For the second point, shades, greenery, and permeable ground can cool off rooms and streets, cut peak energy loads, and slow down stormwater. If we multiply this across many small lots, we will get tangible urban heat and flood relief. The last point is that the value isn't only the building, it is the blueprint. Here, they publish details, they run workshops, and they use local materials so the skills can stay local. By doing this, they create jobs, rights, and maintenance culture, which are the keys to lasting impact. So that's all about the topic I present, Building with Climate, the Art of Passive Design. Thank you for attention. Goodbye.